Here we're going to talk about the third law of thermodynamics and also talk about the entropy of chemical reactions. Let's first look at the third law of thermodynamics. 3 or 4, depending on how you count them, laws of thermodynamics. Here's the third one. We already had the first two. And again, it's a law, which means that we don't derive it from principles, fundamental principles. In fact, it's just a generalization of everyday experience. So, third law of thermodynamics. So what we find, if you measure, for example, the entropy of a solid or entropy of a chemical reaction, you find that as you get closer and closer to absolute 0 Kelvin, the entropy of that reaction decreases and it appears to approach 0. And you could further take this as not only the entropy of a chemical reaction, but the entropy of the actual chemicals, the products and reactions themselves, actually go to 0. What you then, statement of the law of thermodynamics is that the entropy of a solid is 0 at absolute 0. Okay, so that's just extrapolation, but that's the third law of thermodynamics. And you sort of have a little fudge factor here, a little wiggle room. If you find that in fact the entropy of a solid is not 0 at absolute 0, then you say, oh, that solid is not a perfect crystal. So this only applies for a perfect crystal, which means there's no defects in the lattice or anything. So that's one statement of the third law of thermodynamics. The entropy of a solid is 0. The solid being a perfect crystal is 0 at absolute 0 Kelvin. Here's another statement of the third law. Remember that no engine is 100% efficient. So when we talked about heat engines, we said the heat engine, efficiency of a heat engine is 1 minus the temperature of the low temperature reservoir divided by the temperature of the high temperature reservoir. And experience has shown that this is always less than 1. So the efficiency is always less than 1. And again, this is not derived or anything. This is based on our experience. We never can get a 100% efficient engine in which you convert all the heat that we put in the engine into work. So this implies that the low temperature reservoir has to be greater than 0. In other words, if this term were 0, then the efficiency would be 1, but we never see that, therefore that term must be greater than 0. Absolute 0 cannot be obtained because if it could be, then you could have a 100% efficient engine. And we don't see that. Another way to say that is that you cannot devise a way to lower the temperature to absolute 0. All right, so let's try to think of that. All right, so here is something that has, say, T greater than 0. And what you want to do is remove the heat, transfer heat energy out of this until this can go to 0. Well, in order to do that, you need to hook that up to something that has T is equal to 0. So T to 0, you can suck out all the heat and make this T equals 0. But you can't have a T equals 0 if you're trying to get a T equals 0. So this implies that you cannot reach T is equal to 0 by any process in which you try to remove heat from a system. All right, so absolute 0 cannot be reached. So those are 3 statements of the law of thermodynamics.